All right.
So tell me a little bit about your background and what you do at Honeywell.
Sure. Well, it's been an incredible journey. 16 years now at Honeywell. Got to work in North America, in France, in China, and now in Switzerland. I've been part of two different businesses. Originally the turbo business. I came in with Allied Signal back in the late 90s, and then Allied Signal and Honeywell merged, and then the business continued to grow. So I got to see the turbo business go through its first $1 billion year. And now the transportation business is well over $4 billion a year. 2 years ago, I got a unique opportunity to move out of the turbo business over into what we call ACS, so the largest business of Honeywell, to lead a new startup with inside Honeywell where we're taking some very advanced process control technology and bringing it into the automotive space.
So what is ACS?
ACS is it's the largest group in Honeywell. It's about a $17 billion a year business. It's made up of 7 lines of businesses, and those range everything from personal protective equipment to the traditional thermostat, which everyone knows Honeywell for, to gas detection, building automation, process automation, and a number of things in between.
So you say this is a startup. What is this? So I'm with a automotive trade magazine, as you know. What has this got to do with cars?
Well, Honeywell is the world leader in advanced control. By advanced control, I mean really control beyond traditional PID control.
And what's PID?
PID is the normal, proportional, integral, derivative control where you typically have a single input and a single output. So you may have a valve and a sensor, and you try and control the signal on that sensor by moving that one valve. However, today's engines, there's many valves and many sensors, and they're all interrelated, some more than others, and that drives a lot of complexity in how the engine gets developed and controlled and ultimately calibrated to meet the end customer's desire, which is a fuel-efficient, fun-to-drive vehicle. What we are doing is introducing a technology that Honeywell for the last 20 years has perfected in a number of other industries to help the automotive industry address this increased complexity in today's engine designs and allow them to meet tomorrow's emissions and performance requirements.
And what other industries did this get developed in?
So the technology started out in a lot of process industries, so for petroleum refining, for chemical manufacturing, for paper manufacturing, and one of the more sexy industries is in aerospace, where the technology is used to help a number of fighter aircrafts be extremely maneuverable, but yet flyable by a human pilot.
So what does this control technology do for the car? Why would an OEM want to integrate this into their car?
Very good question. So there's really 3 main things that this technology will bring. The first is reduction in development time. So that directly translates to a cost savings for the OEM. It also gives the OEM more time to refine and perfect their designs so that they can get to an ultimate better product for the end consumer. The second thing that the technology does, and this is the one that as an end consumer you'll see the most of, is the vehicle now will have better fuel economy. And on top of that, it'll have better emissions, which will make the OEM's problem statement of meeting regulatory requirements easier. The third benefit that this brings to the OEM and to the end consumer is a more reliable vehicle. You're going to reduce the warranty cost on the vehicle. You're going to improve the diagnosability of the vehicle when it does have a fault. And you're going to make the overall drivability of the vehicle more stable over the life of the vehicle as the engine is aging.
And when you say better fuel economy and better emissions, are we playing at the margins, or is this large impact in emissions and economy of
Sure. So the technology by itself, applied with no other changes, can bring about 1% fuel economy improvement. However, many OEMs have told us that they expect to achieve 3 to 4% fuel economy improvement through the application of the technology and then the optimization of their system by using the inherent benefits of the technology and the additional time they have for development.
And who are you working, what OEMs are you working with at this point, can you say?
So there's a number of OEMs that are working with the technology at this point from a development perspective. We have papers in the public domain with Cummins, papers with MAN. Ford has publicly spoken about some of the advanced work they're doing with us, and then there are a number of other OEMs that will be soon publishing the results from the work that they're doing with us.
And are there people at each of these companies that I could talk to about what they're doing with you and what they see as the benefits?
Absolutely, we can give you a list with names and contact details.
Great. How did this system come to be designed? I mean, how did Honeywell decide to get into this area of the business?
It's an interesting topic there. So back in around 2004, the current CTO for the ACS business joined Honeywell from General Electric, where he was responsible for the powertrain in their locomotives. One of the things that they struggled with was control and calibration of their diesel engines. And at this point in time, the engines were fairly simple in terms of the control challenges. As he got integrated into the Honeywell businesses and he saw the power of the control technology that we had in a number of other non-automotive industries, he challenged the team to see if there was a way that they could bring value into the automotive domain with this technology to solve a problem he personally had struggled with in that job. So the team started the development in early 2004, continued to work through until around 2007 when they validated on the first customer engine. And from there we've continued to mature and grow the offering. In 2011 we put it out into customers' hands for them to start working with it on their own.
Well, thank you very much for taking the time to explain all this to me. Is there anything else you think I should know about it, or anything else you want to give me just so I make sure I have the complete picture?
Sure. Just the key thing here is that the OEMs are spending around $2 billion a year to try and improve the control and calibration of their vehicles. We feel that there's a very big opportunity here to do three things: reduce the time that they spend doing development, therefore enabling them to get better products. Number two, improve the performance of the product that they're selling, so fuel economy and emissions. And number three, improve the reliability and ultimately reduce the warranty cost of the products that they're selling. And those three things are key to everything that we've tried to develop into this offering.
Is anyone else, who are your competitors in this type of work? Is there anyone else doing this?
So there are a number of traditional competitors in the sense of people developing engine control, but when it comes to this technology, Honeywell is in a very unique position to be the only one today bringing advanced scientific control into the automotive space.
Great. Thank you very much.